Hello, hello, and welcome to first day of our webinar workshop series, not sure how to call them, for AAHF 30 course here in Lund University. Let's call it workshop. These workshop series are aimed at teaching you Rhino at an advanced stage, or intermediate stage, I should probably say. And it's going to be tailored for architects, of course, since, we all are architects. So the modeling techniques that I'm going to show are going to be tied to Nurbs geometry type, as well as SubD geometry type. And for that, we will need to use Rhino 7 or newer versions. I'm also going to show you basics of Grasshopper and basic tools that I find to be useful within Grasshopper. That's going to kind of come in at a little later stage. Anyhow, the first thing that I kind of want to do when beginning this workshop is to get the information going, right? Get the information, get the site information going. So here you can see that we have a site in Helsingborg, right? And we have a CAD model that we got from a municipality, and that's usually what you will work with as an architect, right? And just for convenience, even though you have the site in your canvas, on your canvas page, just for convenience, I will also put a link to it in the description of this video so that you can download it. So the first step is always to investigate what you have, what kind of information you have, and gather any information that's missing, and also to just simply clean it up. So first thing that we want to do is we want to make sure that all of the layers are turned on. Right? In my case, they are. Right? In your case, it might be something, some layers might be turned off. So make sure that everything is turned on. And then just type in or use Ctrl-A to select everything on the scene. And type in ZSA or ZS, zoom selected. Right? So that is going to zoom in. It's going to make the viewport zoom into all of the geometry that you have selected, right? And if you have pieces of geometry that are far away on the screen, then that's going to kind of show it for you, right? So Ctrl-A, ZS. If you do have, let me just kind of show an example of it. Just let's draw a quick small rectangle right there. So if we do have some crap that is away from our original drawing, that sometimes happens, all you need to do is just unselect everything, drag around that crap, type in ZS so that you're zoomed into it. In this case, I just drew a rectangle so that I have something to zoom to. And we will just move it to 0, 0, 0 coordinates by selecting it, typing in M, enter, and then just clicking on a corner point, any corner point that we want, just clicking on it and typing in 0 and hitting enter. That's it. Now I will do Ctrl-A, ZS again, zoom selected, and now I can see that my rectangle has been dragged onto the 0, 0, 0 coordinate, right? So this is how you bring back all of the information into one place. Do that. Once you have it in place, you will need to realign it, and you can do that. I would suggest doing that by eye in the top view, and just trying to find anchoring points which would match up between different layers of information. Sometimes it's a little bit more tricky, but hey, if you don't have anything to anchor to, then you will need to kind of approximate it by eye. Either way, have everything stacked as one drawing. Now let's see what we can actually clean up and what we don't need. So the first thing that I notice is that the green layer right here, it seems to have all of the trees. Yeah, it seems like all of the trees are either floating high above or are kind of pushed down right here. I don't want that. And I will just make sure that this layer, besides the trees, is completely flat, because I can see that here everything is kind of grouped into one large group. Let me actually drag it out to the side. I'll Control Z to undo it later, but just right now so that you can see it better. Yeah, it seems like all of the contour lines on the landscape are flat in this case, and the trees are just kind of off the plane. Thankfully, we do have other set of contour lines right here that seem to be, yeah, that seem to be already moved for us, so we won't need to do the boring movement. Either way, let's Control Z this, and let's just simply scale all of this along the z-axis to dimension 0, right? So if you specify that the distance here, the scale of this object along the z-axis is 0, that means it's going to be flattened out. Alternative to that would be just type in project to C-plane and to choose delete input objects as yes. But that doesn't seem like it's gonna do anything, which is strange. It should have done it. I think it's because it's a bunch of blocks. Either way, scaling should do the trick though. So let's try. I select all of it. I click on the scaling little widget here and type in 0. Okay, so some parts got scaled down, others didn't. It feels like it's the block instances that we have, they don't want to get scaled. That's fine. All we need to do to kind of fix it is to get rid of the block instances, right? So to do that, you just type in cell block instance, so that you have all of the blocks selected, and you type in explode. And you can see that it's gonna say 3000 instances exploded into whatever 1000 objects, right? And then you do that again. Cell block, you unselect everything, you type in cell block instance, just to make sure that there are none left, because sometimes you can have nested blocks. Okay, so now coming back to this again, I will select all of the trees here, and I'll select all of the trees in the top, which are like very weirdly positioned here, but it does seem like it's all trees. Always double check, by the way. Yeah, it seems like we have most of them. And there's also some trees here. Perhaps we can do that over layers. Doesn't matter. I'll just scale all of them to 0 so that they are now flat. Perfect. So we have all of the trees and all of the contour lines there being all flat and dandy. Let's just make sure that the layer is correct. So if I select one of the trees, one closed curve, right? The layer is 0, which is really, I don't like that. But it seems like only the trees are in that layer, which I do like. So we are going to, for now, just drag them all down. Just investigate to make sure that it's only trees. That's some weird stuff right there, but that's fine. Yeah, okay, sure. So I'll select all of them and I'll just scale them down to 0. Finally, we have all of the trees in one layer. Wasn't that hard. In terms of the contour lines of the landscape, since we have the ones that are actually lifted, we don't really need this layer of information, so I'm just going to delete all of them. We will be deleting all of the stuff that we don't need, and that's just kind of just there costing us time and resources. So now in terms of the contour lines, I have just selected one of these, and I'm just going to drag them up a little bit so that I have a separate layer. We have the contour lines, and I want to make sure that these contour lines don't have any additional information that might mess up our landscape once we're doing the landscape, making the 3D model of the landscape. So I'm just going to isolate the contour lines, and I'll just kind of visually inspect. Give me a second. That's weird, but that seems to be okay. Yeah, okay. All of these seem to be just the landscape contour lines, so we're gonna give it a pass. Once you've done inspecting it, you can unisolate, and that's going to bring back all of the additional layers here. So actually, let's talk about these additional layers. Let's select these and isolate them out. And let's see what we have here. Well, we have a bunch of points. Do we need points? We don't really need points. Cell PT. Cell PT, and hit enter. That's going to select all of the points, and then hit delete. Okay, so the points are gone. Then what do we have here? We have a bunch of text as well, and it's all, by the way, blocked, but that's fine. We can delete stuff from blocks as long as we use the cell and then something command. So in this case, do we need text? Let's investigate. Since it doesn't really have any it doesn't seem to be adding any value to us, so we will be deleting the text. Cell text, and just hit delete. That's it. That was easy. Everything else I'm going to keep. I feel like it might come in handy, right? And it's still a single group, which is nice. Well, I lie, it's not a single group. Wait, let's actually hide the group and see what's left. Oh, okay, so all of these are going to be green. So all of these are trees or greenery, which we are able to just kind of move down and have them as a separate information layer. And everything else here, well, I will just group it for now so that we don't miss it. So that it's easy for us to select it, group. And also let's just group the trees as well. Okay, now it's time to show all of the layers. Why is this still here? Wait, was that a duplicate? Feels like that's a duplicate, isn't it? Let's move this up and see. Okay, so that information that we got was indeed a duplicate that was just there, so we don't need it. I'm just gonna delete the grouped trees, the bottom layer that we had. Not sure why it was like that, but it was. Either way, now it's time to actually kind of start making cool stuff. So for the trees, I'm just going to group them. The top tree layer, I'm just gonna group it. The landscape curves layer, I'm also gonna group. And the city, like the let's call it the rest layer, I'm going to, I think it's already, yeah, it's grouped. So I'm just going to bring the tree layer onto the city layer, right? I'm just going to merge them into one. And to do that, you can just select the trees All right, you select the group, you type in M, enter, and here you specify vertical, right? Vertical. So now when you move it, it is locked to the vertical direction, meaning that you can snap to any point here on this flat drawing, and it's going to fail because of course it would. Let's try again. Select this, M, enter, V, enter for vertical. From here to here. Is it? Yeah, now it's in the same lane. I'm not sure why it didn't snap properly before. Either way, we have the information layer and we have the landscape layer, and we now want to create a 3D object of the landscape layer. Before we move on, I will just type in purge and just choose yes on everything. Hit enter, so that it removes all of the layers, for instance, that are not being used, and it removes all the materials that are not being used, and so on. So you can see that it purged 24 layers from our layer list. Okay, let's create a new layer, call it CAD data, and I'll just select all of the layers, holding down the shift key and clicking on the first and the last one. Select all of the layers and just drag them into the CAD data layer like that. And also these as well, except for the default layer, like that. So now we have full control over the visibility of everything with just a single click. All right, time for some grasshopper. Type in grasshopper, wait for it to load. And while it's loading, we are going to be creating a landscape. We're going to be creating a 3-dimensional landscape from this, and you could do this with a patch tool in Rhino, but Grasshopper has a much stronger option or a stronger workflow than what a patch tool does. So we're going to use that. You will need Weaverbird as one of the plugins that are, or add-ons that are installed to Grasshopper. And to get Weaverbird, to get Weaverbird, you just type in Grasshopper Weaverbird on Google, and you find it's the second link, right? GiulioPiacentino.com. Sure. I'm really bad at reading names, but you get to this website, right? And here you just download Weaverbird for Rhino 6 plus 7. It's going to download the Grasshopper definition, which you will be able to just drag and drop. Wait just a second. Yeah. You will be able to drag and drop it into your Grasshopper file, just like that. Drag and drop. And it's not, if you don't have Weaverbird installed, it's not going to load. Instead, it's going to say, would you like to download Weaverbird? And that is where you click the download and install button. And then it's going to, maybe it's going to ask you to restart. I don't remember, but you will, by the end of it, you will have Weaverbird installed. So do that. And once you have it, let's just close that. We don't need it. We will create a definition for this to work. So we have a bunch of curves. We want to create a landscape, a 3-dimensional landscape from these curves. What do we do? Well, first of all, we need to link the curves into Grasshopper, right? So I'm just going to type in CRV curve, right? As a this hexagon, black hexagon icon thing, curve. Click on it. And that is going to create a curve container for me. And let me just do something that you don't need to do, but I do. Bifocals. Let's just put it there. This will just show what the names of the nodes. So anything that is a black, that has a black hexagon icon is a container that basically doesn't do anything. It just stores data, right? And in this case, it's waiting for us to give it a bunch of curves. So, oh yeah, we do have a bunch of curves. I'm going to select all of these contour lines, not the other stuff. We don't care about the other stuff. We care about the contour lines. I'm going to select those, right click on the curve component and choose set multiple curves. Bam. Now these are linked, and you can see that if I click on this, it turns green. If I unclick, it's red, right? Or brownish red. Don't worry about the numbers here. I can actually, there we go. That's going to be better. So now we have a bunch of curves. What we want to do with them is we want to create a mesh between them. So what is a mesh? A mesh is basically a series of triangles and quads that are described with two lists. And I can kind of show you this, just a second. Like that mesh geometry. Right. So for instance, this dolphin, right? This dolphin is a mesh, and you can see that this dolphin is made out of these triangles, right? Alternative would be, let me just quickly try and find, yeah, this. Both triangles and quads, still a mesh. So the way a mesh is kind of defined, let's do, wait, I need to do this, that, copy image, Photoshop, let's paste it here, make the boy bigger, there we go. Where's my mouse? There it is. And let's just change the color to red. And let's just make it smaller. So that's a point in a mesh. And that's a point in a mesh. And that's a point in a mesh. And here are 3 points. And so on, right? So it's a collection of points. Actually, a lot of points, right? So points in a mesh are called vertices, right? And basically, the way of how mesh geometry is described is via 2 lists. One list is these vertices and the positions of them, right? So vertice number 1, x, y, z coordinates of where this vertice is located, right? Then vertice number 2, this guy right here, x1, comma, y1, comma, z1, right? Then vertice number 3, just to be clear, x2, y2, z2, and blah, 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 right? Just a list of points, right? That's the first list. If you just do that, if you just kind of gather that, then you would get a point cloud, which is, all right, let me show you. Come on. Point cloud, which is basically this, right? A bunch of points just floating in the space. So you need a second list. And the second list is the face information. So let's say this polygon right here, right? This guy right here has 4 vertices. Vertex 1, vertex 2, vertex 3, and vertex 4, right? So the second list for would be quad and then in commas, quad because it's a rectangle, right? And then in comma, not in comma, in brackets. In brackets, I would say quad between vertex 1, vertex 2, vertex 3, and vertex 4, right? And the second one would be, let's say this is 5, this is 6. Then the second one would be quad between vertex 4, vertex 3, vertex 5, and vertex 6. And so on, right? By the way, if it's a triangle, then you just say triangle and then, you know, A, B, C. So you don't need 4 anymore. Meshes can have more than 4 vertices or 4 corners, but they are then called n-gons, and you should stay away from n-gons. N-gons are bad. I'm not gonna go deeper into that. Let's just say n-gons are bad. So that's how it works, right? You have 2 lists that come together in creating a form, any form. This type of geometry is very fast. It's very fast to visualize, it's very fast to calculate. Nurbs geometry, well, we're gonna talk about other 2 later. Just keep in mind, there is mesh, there is Nurbs, and there is SubD. And then Rhino, in Rhino, SubD is a geometry type that is somewhere between mesh and Nurbs. And I'm gonna touch on this quite a bit later down the line, but for now that's all you need to know. Alrighty then, let's go back here. We want to create a mesh from these curves. How do we do that? Well, we need a set of points, and we need a rule set of how those points are going to be assembled into faces, into what's called mesh polygons, you know, those quads and triangles. So first of all, a set of points. I could just say, yo, give me all of the points where the curves break, but that would be way too many points in my opinion. Let's actually just test it. Don't follow me right now. Don't do it. Let me test it because I'm afraid that your computers might not handle it. Discontinuity. Like that. Okay, and how many? Okay, that's 500,000 points. So basically this curve component, or not curve component, but all of the curves that are existing here, if we were to add up all of their corner points, we would end up with 500,000 points. That's too many. We're not going to do that. Instead, what we're going to do is we're going to divide each curve along a length, right? So divide length. And we're going to specify what's the length that we're using. So here in the bottom, you can see that we're dealing with this in meters, right? So our units are in meters. And also, this is a very large scale site, right? So I don't think we will gain anything if our resolution is going to be lower than a meter, right? So let's, for divide length, for the L input, let's create a slider between 0.500, this is how you create a slider, by the way, dot 1.500. I will explain this in just a second, but the format is, if you want to create a number slider, right, you first write the smallest number of the range, then you type in dot dot, and then you write the largest number of the range, and then hit enter. And now we can see we have a number slider that goes between 0.5 and 1. If I want a slider between 22 and 58, then I do 22 dot dot 58, right? If I want the slider to have a higher resolution, then I do 22.000 dot dot 58.000, enter, right? That's how it works. But in this case, we just use this slider of 0.5, and let's for now just do, by the way, if you double click on the slider here on this range, if you double click, you can type in a number as long as it's within the bounds, right? So type in 1, connect it to the L, and let's see if that's gonna help us out even a tiny bit. Okay, so that cuts down the amount of points. By the way, I'm hovering my mouse over the P output, which is the point output, to see how many points I get. And that cuts down the amount of points to 318,000 rather than whatever it was before, 500,000. So that's a pretty good removal of points. I want it to be even less, so I'm going to say instead of length 1, let's double click and let's type in 1.5. So our step size between the points is going to be like 1.5 meters right here. 212,000. Okay. With 212,000, I think we can begin. Still seems to be very dense, doesn't it? Let's look at it in the top view and let's just try to envision it. So it does seem to be very, very dense. I don't like it. So I'm going to increase it even further. I'm gonna say, if that is 1.5, let's do 2. So I'm just going to create a slider between 1.500 dot dot 2.500. Just type in 2 here, connect that. Yeah, that seems to be a little bit more reasonable, and we end up with 160,000 points. Okay, that's a amount that like a average computer can handle. And then we will use a tool that's called Delaunay mesh. Who knows how to pronounce that? So under the mesh tab, under triangulation, here you can see Delaunay, I don't know, mesh. Click that, choose that, and just connect your, no, wait, don't connect, not yet. Stop, don't. First, we need all of the points to be in the same list. Right now, they are not. The way this works is when you divide each curve individually or separately, when you divide all of these curves that are separate curves, right? It's going to create a bunch of separate lists. For each curve, it's going to create a separate list of points, right? Which live in their own little world, and you have a bunch of these lists. You don't want that. You want all of them to be in one big happy family list, and then the Delaunay mesh will be able to create a triangulation between them. So that's the plan. So for divide length, you will need to right click on the P output and choose to flatten the data tree. Flatten means get everything into one list, basically. Bam, wait for it, great. And then let's connect it to Delaunay, and this might take a while. Well, it actually didn't. I'm surprised. The way this works, the way this tool works is it basically, for each point, it tries to find the closest well, it's much more complicated than that, but let's just say it tries to find the 6 closest points, I think, to each point, and it tries to create like a triangulated mesh out of it. So that seems to be working quite well, honestly. Let's take a look. Let's turn off divide length preview by just selecting it, clicking the scroll wheel, and choosing a blindfolded guy at 2 o'clock. Like that. And also, let's turn on the mesh edge preview. So you go to display, preview mesh edges. Control M is the shortcut. That is going to show you all of the triangles that it has created. And it seems like it's a little bit of a mess, but I think this is gonna work. Let's check it. Let's check it out. Let's switch from perspective, from wireframe view. Let's switch to Arctic view. Then let's create a custom preview for the Delaunay mesh. Custom preview. Like that. And let's disable the preview of the Delaunay mesh. Can't wait for this to stop, for us to stop using this node. Okay, so that's what we get, and it seems like it's following pretty nicely. Okay, so now as we have the site or the master plan thing generated, the landscape for it at least, we want to be more specific, and we want to choose our own site in which we will work. So to do that, I need 2 data points. One data point will come from me, right? Where I'll just specify a rectangle of, let's say this area right here is what I'm interested in, right? So that's gonna come in a little bit later, but the more important data point is the satellite imagery, because it's pretty hard to orient yourselves within, this mess. If I were to just delete the custom preview node, then we would see, the whole damn thing. And here it's of course much easier to orient, but just as an additional layer of information, I do want that satellite imagery. So to get that, all we need to do is just, maps.google.com, and we will go to Helsingborg, and where was it? Oh my god. Östra Ramlösa, somewhere. Oh my god, no, please. Let's change this to a satellite imagery, and it's gonna be right here. Yeah, that's the site right here. So I'm just going to quickly Windows key Shift S and drag around the area. Windows key Shift S is a very, very useful tool, by the way. It just gives me, it's like a snipping tool, I think, or whatever it's called, but it enables me to do a partial print screen. And then in Rhino, I will just Control V to paste it. It will ask me to draw it as a rectangle, so I'm gonna do that. Precisely like that. And that's it. It's pasted now. So to get the scale at least somewhat correct, I will need to choose 2 points, right? And in this case, I will say, this point, and let's turn off the ortho, and this point. So I'll just specify this curve, and I'll need to match them with these 2 points right here. This point here, and this point right here. How do we do that? Well, we just grab the whole damn image together with the curve that we just drew. We move it, enter, from, let's say, this point right here to our, this is gonna be a little bit annoying, but to this point right here. So we just moved it. And now we will need to scale. So I'll just type in scale between this point, the end of the line, and then to the end of the reference line right here. It's slightly misaligned, but I think that's okay. We can double check by looking at different areas if the misalignment is too drastic. It doesn't seem like it is. Yeah, there's a little bit of misalignment there. But besides that, it's kind of good enough. Like, it's good enough to have this as kind of side information right here. Right? So we do that, and then now when I have this imagery right here, satellite imagery, I can just very easily specify that, oh, you know, this is the area in which I want to work, right? Or whatever. So here I am going to create a polyline, a rectangle, saying that maybe this area is where I wanna do my business, right here, right? Something like that. And when you will be specifying it, make sure that you're using 4 corner points, not 5, not 3, but 4, a rectangular boundary. This is just going to be much more helpful for you in the long run. Also, just using a rectangle tool will be even easier to later work with. So maybe something like that. The size of and the proportion of your side doesn't matter that much. Just make sure not to do too much, because later you will need to kind of solve it all, right? So something like that. For now, I think that's gonna be okay. Maybe even a little bit larger, like that. Okay, we have this area here specified, but we actually want it to be on the drawing, or rather on the mesh that we have created, right? So we do it by just moving the rectangle that we drew from, you know, our trusted reference point to our little point that we've created right here, right? So now it's located here, and then we do, we reference it in as a curve, CRV, curve, set one curve, and now it's linked to Grasshopper for future use. With these boundaries, what I like to do is I like to go into perspective mode, and let's just change this to shaded. And I like to drag them high up, right above every other layer that I'm working with, just so that I don't lose it and it's easy for me to select it and change it. And later, once I need to kind of project it and work with it, it's easy for me to kind of know where the projection is, if that makes any from which direction I need to project. So it's always downwards, right? So we have this going on. Now, the key thing here that we will need to do is we will need to construct a volume, or not a volume, sorry, my apologies, a surface, a clean surface from this mesh only within this portion of the mesh. So the way I want to do it is pretty simple actually. Inside of this curve, we will create a grid of points, a very dense grid of points. We will take that grid of points and we will project it onto the mesh so that it kind of gets projected straight down. And then thus we will have like a three-dimensional grid of points, right? A grid of points that is following the surface of the landscape. And then we will create a surface from that grid of points, right? So that's the idea. The way you do it is if we have a curve here, we can create a boundary surface from it, just like that, right? So now it becomes a surface. And then since we have it as a boundary surface, we can say, okay, divide surface. Divide surface, create a grid of UV points on a surface. Great, that's what we want. So surface comes in to surface input. Then it asks us for two more inputs, U and V. That's how many divisions you will have in U direction and V direction. Keep in mind, UVW is local values of X, Y, Z. So you can read it as X and Y right here. So for this, I will create a slider that is going to be somewhere between, let's say, 100, ... and 300. Or, yeah, let's do 300. Why not? 100, ... 300. Like that. Connect it to both U and V so that it has the same amount of points in X and Y direction. Right? So you can see a very dense grid. Let me actually start hiding things because I feel like it's a little bit, visually, it's a little bit hard to follow. So I'm just going to select everything in here, except for my rectangle, and hide. So that I only have my rectangle here, zoom selected to it. So now you can easily see the grid of points that is being created. And it's actually, you might think that it's creating 100 by 100 points. That is not the case. It's actually creating 101 by 101 points. The reason for that is, I've explained this so many times. The reason for that is if you have a line, right? You have a curve and you say, yo, I want to divide this curve into two segments, right? What do? You cut it here. How many points does this polyline then have? Well, it has the start point, it has the midpoint, and it has the end point, right? So it has two segments, has 3 points. Okay, let's say you want to divide this curve into, I don't know, 6 elements. Right, into 6 smaller curves. Well, or let's do 8 because I'm lazy and I don't want to redraw it. you wanna do 8 elements. Well, then you divide it up like that, right? 1, 2, 3, 4. Oh, sorry. Like that. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, great. 8 elements. And how many points do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So it's always +1. Always. The amount of kind of divisions and the amount of points, the points are always +1. So keep that in mind. This repeats throughout every grasshopper definition that we do. Right, so we have that. We have 101 points by 101 points grid. Then we want to take those points and we want to push them down onto this mesh right here, right? So I'm going to use project point tool. Okay, project point asks me for 3 inputs. The points to project, great, we have those, here they are. Just straight up connect them like so. Then it asks us for direction of the projection. So the direction is, it needs to be straight down, right? So it's Z, only that it's minus, right? So Z direction and -1, right? So if you have, you know, vector X, vector Y, and vector Z, then it would be this guy, but it's -1, for instance, or -10, doesn't matter. The strength of it doesn't matter. What matters is the direction. So as long as it's a negative value, it's fine. So you would do negative like that. Actually, by default, project point, that default input here, if I hover my mouse, you can see 0, 0, -1. It already has it incorporated. So it's already trying to project the points straight down. So we don't need to do all of this. It already has it. The last input here is geometry to project onto, and that is going to be our mesh. And I'm just going to, just for it to be clean, I'm going to grab all of these, sorry, all of these nodes, and I'm going to move them down like that, so that when I connect the wire, like so, it doesn't cross, right? The wires don't cross. Or else it would be like that, right? I don't want that. Just visually. So now we have a little bit bigger definition, where you can see that the points now are being projected on the mesh, and they are not flat anymore. If I were to hide the mesh, you can see that the points are actually being moved in that direction. That's what we want. Yeah. Okay, so now as we have it, I think 100 points is good enough, but I could increase this to 200 just to show you. You know, so that is like twice as high of a density. I don't think we need that amount of density. Maybe something like 150 will do the trick. It depends on how big your rectangle is, of course, right? That's the biggest influence over how many points you want to use. So we have a bunch of points. For this to work, now to create a surface from these points, I will create a surface from points component. Yep, it's very, very literal. You know, surface from points. Grab that. Asks us for a grid of points, asks us for number of points in U direction, and asks us, would we like to interpolate? Okay, let's talk about interpolate. I don't want to talk about interpolate. You always keep this as false. Cool? We're good? Just always don't touch that. Always false. That's gonna be for the advanced tutorial. This is an intermediate tutorial. Instead, points and number of points. Okay, so project point, we connect that straight up from P to P. That's easy. And then for number of points, we need to specify, okay, so how many points do we have here in one single line? Because from that it can understand, you know, how it needs to count. Remember when I said that it's not actually going to be 150 in this case? It's 151. So we need to account for that. And this is where parametricism kind of shines. We can very easily say 150, okay, addition plus 1, right? Like that. And then it doesn't matter what kind of a number you have here. It's always going to spit out here +1, right? 151 in this case. And we connect that to our U input here. Just like that. Let me clean this up a bit. Like that. Alrighty. So, you probably have noticed that this turns red. And it turns red, if you zoom into it, you can see the error message by clicking on this red balloon in the top right corner. Surface could not be fitted. Well, that doesn't help us at all. Let's see. For different nodes, different errors mean different things, which is, I know, hard to kind of grasp, and it's very hard to explain, but the more errors you get and the more errors you solve, the more you will understand what's going on wrong. So you need to kind of understand the inner workings of every node. And in this case, I assume it's complaining because all of the projected points are coming in as separate, within separate lists. So every row of points is within a list of its own. And you can see that it's a separate list because of the way this wire is drawn. So let's talk about wires for just a second. If a wire is just this gray wire, that means one thing is going through that wire. One number, one curve, one letter, one mesh, doesn't matter, one thing, right? So in this case, a single rectangle is going through this wire. If a wire is like this, like either you can read it as a thickened wire or double wire. If a wire is like this, that means multiple objects, a list of objects are going through it. A few numbers, a few curves, and so on. So in this case, it's all of these curves that are going through this wire. So it gets thickened. If a wire is dashed, that means a list of lists is going through that wire, right? So a grafted data tree. So in this case, we have a list of lists of points that are going through, right? So this row right here, this row is one list. This row is a second list, this row is a third list, and so on, right? So we have a list of lists. Okay, how do we fix that? Well, we already know that trick. We just flatten everything into one big happy family. So we right click on the P output and we choose to flatten. And then what it does, it takes all of the lists and it just pushes all of them into one big list. So once one row ends, it just slaps on the second row and the third row and so on. So you can already see that a surface is created, but there's too much junk. So I'm going to select everything like that, disable preview of everything, and just look at the nice little projected geometry right here. Now the cool part is if I take this rectangle and I move it to the side, it's going to generate a different portion of the landscape for me. If I take a single point of it, it's going to generate, you know, a different kind of boundary. So this is a very cool little definition where you can clean up any kind of a curve set into a small kind of boundary of whatchamacallit, a landscape boundary. That's what I was trying to say. Alrighty, now this surface right here that we have is, well, first of all, it has a very large resolution, and that's fine for what we're going to be doing next. So I'm going to keep it, but later down the line, we will want to rebuild this into a little bit of a softer geometry. And we'll do that with SubD tools, but that's later. For now, we do have a clean landscape here. Let us bake this out. So to bake this, I will indeed create a new layer and call it my landscape, like that. Color it. Maybe, or actually let's keep it black. That's fine. And I'll just right click on the last node, on the icon of the last node, and choose to bake. And then choose my landscape, hit OK, and now it becomes a geometry that is selectable and you can operate with it in Rhino. So once that is done, I can just disable the preview of my node and I can kind of group all of this. So you select all of the nodes, you group them by clicking the scroll wheel and choosing to group, and you can just right click on the group then and here you can type in the name of it. So I'm just gonna call it landscape generator, landscape generator. Great. Now we have ourselves a little group here. File, save document, just save it to wherever you want to save it. I'll just call this workshop day 1. So that's going to be our grasshopper file for today. You can have like multiple different functionalities in one file. I suggest you do that because you can get lost between different files quite easily. Okay, so we have that done, right? We have that cleaned up. Now I can do show selected. Let's wait for it to load in and then select. Honestly, let's select everything and just show everything. And here you can see the landscape that is fitted quite well onto the geometry. Onto the contour lines. The layer with additional information though, that layer will need to be, what's the word that I'm looking for? This layer right here will not be that useful as it is right now because it's underneath. So the way you can kind of bring it back is by just pushing it up. I would get this image as well, pushing it above like that. And then looking at it all via, why is this lagging? Wait. There we go. So, and then looking at it via top view. Shade it. And just seeing what's going on here and there. Right now, I will not be drawing or cutting the geometry, the landscape geometry with the street curves, for instance. I will not be planting trees because I want to first sketch out what I want to do and how I want to change things. So one thing that you might want to kind of check out is a tool that's called EMap. So if you select your object, in this case the landscape, and you type in EMap and click anywhere else, oh yeah, we need to zoom into it though. It's going to show you this object as a very, very glossy surface, right? Oops. Very, very glossy surface. And with that, you can start seeing that there are indeed issues and problems with the surface. You know, that it's not as smooth as it might be. And that is honestly for anything that we will do, that is absolutely fine. It's just that with the reflection on, with environment map on, it's much easier to comprehend the three-dimensionality of an object and understand where it's bending, how it's bending, and so on. So just keep in mind, EMap is pretty great. With that said, I am going to go to the top view, and I'm going to draw out or sketch out a concept of how I envision my pavilion, my objects are gonna look like, or my naturum is going to look like within this site, right? So I could just do the snippet tool, you know, Windows key Shift S, just grab it like that, get it into Photoshop, scale it up. Oh, where's my pen? And then just start. Hello, where are we? Yeah, there we go. And then just start kind of thinking about where the bus stop is, where the possible entrance points are, and mapping those out, marking those out. Right? So that would be definitely one of the solutions. What the hell am I doing here? Stop that. No, that's too thick. That's good enough. That's good enough. Even thinner. Yeah, that's fine. So you could start kind of thinking about possible entry points and possible kind of anchoring points that way, right? And just trying to see how this whole thing could kind of connect to the fabric of the city. Perhaps there could be a larger merger right here. Perhaps not, because we have, it's either a bridge here or yeah, it seems like it's a bridge. So it might be, we might get a merger going on here. Anyway, you could start sketching, right? Either by pen and paper or with your computers. In my case, what I prefer to do is 3D modeling. So I prefer to kind of model out initial response to the site and to the program as how I see fit, right? So coming back into Rhino, I would just look at the geometry and perhaps even hide the landscape for just a bit, or not just the landscape, hide everything for just a bit. Control A, hide, and I would model out something in complete vacuum, right? And that would be a very, very small step. And from it, I would move on to merging it with the landscape as soon as possible, right? Or else you would be risking of it just being, you know, a plopped on nonsense in the landscape. But the volume of it, I kind of want to first at least understand the form that I'm after. So I'm not going to kind of be prescriptive as to what kind of form you need to do, and I'm just going to do my own. So in my case, to explain the other two geometry types, I'm going to move into modeling the same form in Nurbs and also in SubD, right? So let's start with Nurbs. Let's say I want to do a box. Let's just start with a box. And let's say my box is 15 meters by 7.5 meters, or let's do by 10 meters. And the height of it is, doesn't matter. What did we use? We used 10, right? So let's use 10 again. Something like that. So we have a box, right? If we were to do the same thing with SubD tools, right? So here we have the SubD tools rollout, and there is a SubD box option here, create SubD box. Right now we don't really care about any of these settings. I just want to create a box, and I'll start from, doesn't matter, from here, and then I'll just type it in as I did before. It was 15 meters, enter, by 10 meters by 10 meters, right? It actually creates an egg for us. So how are these two different, or how are these the same? How can both of these be called the box? Well, if I hit the tab button, tab, T-A-B, if I hit the tab button, you can see that the SubD geometry switches between being an egg and a box. And the reason behind it is pretty interesting. It's within the name, actually. The box gets subdivided infinitely until it gets rounded off perfectly, right? So as you are taking a geometry and you're dividing it into smaller bits and pieces, the existing points that you have will get averaged out, will get smoothed out, right? So you end up with, if you take a rectangle and you divide it, you're gonna end up with an octagon. It's not actually going to be an octagon, but let's just ignore the fact that I'm lying to you right now. And then you divide the octagon even further, so you get something like this, and so on, right? So it always smooths out the sharp corners, and by the end of it, from a rectangle you get a circle, right? And from a cube you get a sphere. That's how it works. So here the SubD geometry is very interesting in that regard. There are a lot of benefits of doing it with SubD, and I'll show you all of them. But for now, this is kind of the first brush with it, the first introduction with it. So we have this box. Let's make it a little bit more interesting. I'm just going to grab this surface here, right here, of the box. So we can do that by holding Control Shift, and clicking on the surface. This is what's called the sub-object edit mode, where you can Control Shift, click on an edge, you can click on a vertice, or you can click on a surface, right? So we can select elements of a closed shape, of a polysurface that way, as well as the SubD shape, as well as the mesh. So Control Shift, click on the surface, and then holding down the Shift key, I will just scale it down, like that. When you hold down the Shift key, it scales in all directions at the same time. So we get a spiky boy. Maybe it's a little bit too spiky. Maybe something like that. Great. Then we will start messing around with it. So I still know that it's that the proportion of it is 10 by 10 meters, right? So 100 square meters are packed in here. So I kind of, when I'm doing this kind of exploration of form, I always think about the size of things, so that I don't need to later mess with it too much. So we have that. Perhaps I need another one. Maybe this one is just doing something like that. And here we will need to scale it. And you can see that, oops, that was a wrong button. Control Shift, scale. You can see that it still retains the scaling, and not information, but as long as you're scaling uniformly, it doesn't matter what kind of orientation your surface has. So something like that. Okay, that's good. And maybe this gets rotated outwards like that. Yeah, something like this. And for instance here, right? Now I really want this one to be a little bit more outgoing, a little bit more, a little bit longer. How do I do that? This is important. Listen up. If you just select it, you can see the direction of movement is not that great, right? I can't be accurate with it. So instead, what you need to do is you need to change the whole orientation of the C-plane, the world, right? Right now, the C-plane is here. X and Y direction, you know, this grid. You want to reorient it. How do you do that? Well, under C-planes, where is it? C-planes, there we go, the tab. Right here, there is an option for set C-plane by 3 points. This one, I love this option. So we choose this tool, and then I specify the bottom left corner of my new C-plane, bottom right corner of my new C-plane, and top left corner of my new C-plane. And you can see that it then realigns the whole world to fit with it. So then I can just take this, and as I select it, you can see that my gumball is now oriented along the directions of the C-plane, the new directions, right? Which is pretty damn cool. So to not to fix that, but if this doesn't work, if the gumball is still kind of whatever, going in whatever directions, then make sure that under gumball here in the bottom, if you right click it, that here it's set to be, where is it? Aligned to C-plane, not aligned to world. That's important. Aligned to C-plane. Okay, so now Control Shift click, and now I can easily drag this out and mess with it further, like that. You know, I get a little bit of a more of a spiky boy, and then, yeah, honestly, nothing else I want to do right now. But you can do a lot of cool stuff. I'll try to show you as much as possible during these days. So we have that. To reset the C-plane, you just click on the Set C-plane World Top button right here. Or you can type in, by the way, C-plane, enter, W for short for world, T. C-plane, enter, W, enter, T, enter. Resets the C-plane to world top, like a regular XY C-plane. Okay, so we have like literally 2 boxes. I need to speed up. We have 2 boxes. Let's do one more. Like that. So it's gonna be a spiky boy. Something like that. Maybe like this. That's cool. Kind of wanted this to extend even further, honestly. Maybe we can do it this way. So if I grab this edge, for instance, here. Oh, grab it. Come on. Grab this edge. Control Shift, click. And then type in move. I can move it from this point anywhere on this edge because I have the near snap turned on. I can move it from here outwards, inherently just kind of creating this opening right here. I think that's fine. Then there is a little bit of a weird stuff going on there which we need to address. So I'm looking at how the objects intersect as well. The bottom doesn't matter. I'm gonna try to cut off the bottom, but we get something like this, okay, as an object. And then I might kind of just go a little bit more crazy with this, and I'll just select all of this, Boolean union them together. Boolean union merges everything into one shape, right? I will rotate it. Come on. Select the object. God damn it. Select the object, hold the Alt key, and do you need to hold the Shift key? No, you don't. Just hold the Alt key, left hand side Alt key, and click on the arc and just rotate it. Like that. Move it down. Drag it out. Okay. And then let's rotate this whole thing a little bit along around the Z-axis, like that. Okay, it's getting even weirder. That's great. We want it to be super weird. That's fine with us. Okay, and now as we have it, we just Boolean union them together again. Boolean union. That's a little bit of a weird thing, but whatever. As you can see, I'm going for something a little bit more crystalline, a little bit, you know, in that department, right? Right, so now the last thing is I kind of want this whole thing to somehow interact with the landscape. So I'll need to figure out a strategy of how it's going to do that. But we're going to do the interaction next in the second part. In the first part, I'm still going to kind of work with this as a separate entity in a vacuum. So as we have this, I'll make a copy of it, and we will take a look at how this can be replicated with SubD tools, right? So let me show you. I will start by showing you a trick, a small little trick that, or actually no. Trick will come in last because I first need to teach you the basics of SubD so that we can do the trick. So actually, let me delete it just for a second and let's talk about SubD geometry, right? Under the tab SubD tools, there are these tools of SubD, right? And there are only a few ones that are actually useful for us. Most of these are highly kind of niche and utility based. So for instance, this tool right here, create a single SubD face, is my go-to, something that I use quite a bit. And the way it works is literally how a surface from 4 corner points works. You select it, it asks you to give it pick a point, so you just click. Asks you to pick a point again, sure, click. Asks you to pick a point again, sure. And once more, and then it will keep asking you to pick points, but after point number 4 you stop, so you just hit enter, right? And then it kind of finishes the rectangle. Don't mind that it's red. I'll explain why mine is red in just a second, but don't mind the red color. So it finishes the rectangle, right? And then you can pick a point again and kind of continue growing the single SubD face, you know, face by face, basically. Okay, we're done. So I hit enter again, and we have this rectangle. I hit tab. It smooths out into an egg again, right? So there's a theme. This method of working, of just kind of creating surface after surface after surface and joining them up and seeing how they smooth out, is a very strong method in my opinion, and something that you all should kind of experiment with. So that's what we're going to actually be doing. But before we do that, I need to explain a few more things. So first of all, red color. Red color is because of the display settings that I'm using. So here under display settings, I am coloring the back faces. So color back faces is turned on and the color is set to red. So this is the back face of it. And you can see that the front face is actually upside down. It's looking downwards. So I know that this polygon is upside down and I can just easily select it and flip it so that it's looking up. Easy. Okay, let's talk about control of SubD. If I were to create again a SubD box right here, SubD box. Now let's look at the settings. So there's diagonal 3-point, we don't care about those. We care about X count, Y count, Z count. That is how many divisions, how many edges it has between along its length, along its width, and along its height. So let's do 1, 1, 1. If you don't have it 1, 1, 1, just click on X count, type in 1, enter. Click on Y count, type in 1, enter. Z count, 1, enter. And then just draw out a box, any kind of box, doesn't matter. Right? Hit tab, you can see it's rounded off. Okay, cool. Now, under SubD tools, again, box, but this time X count do 10, Y count do 10, Z count do 10, and draw out the SubD box again. Much more subdivisions, right? Hit tab, and it somehow magically holds its form much better. And that is the most important thing to understand about SubD, is the closer two edges are to each other, the better they're going to hold that corner between the two edges, right? So to explain this visually, I'm going to delete these and I'm going to create a SubD box, one more, but this time it's going to be 2 by 2 by 2, X, Y, Z, 2, 2, 2, just any kind of a box, bam, like that, right? We have ourselves a box. And now I'm going to do Control Shift, and I'm going to double click on the edge right here, or this edge, doesn't matter, but on the edge on the surface right here. I'm going to double click on this. Click, click, come on, click, click. When you do that, it's going to select all of the edges that are within the same edge loop, right? So let me unselect this and do it for this edge loop, for instance, or for this edge loop. No, so double clicking selects that. That's why you, by the way, want to work with quads and not triangles. That's for later, but just so that you know. Okay, so we have this edge loop selected. Then if I hit the tab button, or let's not hit the tab button. Let's keep this as unshaded, oh sorry, unsmoothed or flat shading. I am going to move this edge loop close to, let's say, the left corner edge, I don't know, left face of the box, left side of the box, something like that. So it's very close. And then I hit tab, and what happens is you can see that this became much sharper and this got smoothed out much more, right? And if I were to show it to you what's happening in a softened version, in a softened preview, if I move this from left to right, you can see that now the right hand side gets sharpened. Now the left hand side gets sharpened, right? So you can control the sharpness with it. Let's do one thing. Let's move this edge loop here. Let's move the horizontal edge loop up like that. And let's move the edge loop that's around the x-axis also to that corner like that. So I'm basically just creating a very strong framing for this corner. If I hit tab, you can see that we're almost back to this being a perfectly sharp corner, right? Can you make an infinitely sharp corner with SubD? Yes, you can, and that command is called Crease. But if I were to show you, okay, let me show you Crease. So let me just select these two edges and type in Crease, hit enter. First of all, you will see that the lines become bold, are shaded in bold. And if I hit tab, you can see that now this is very sharp, right? This edge is very sharp, but also it tends to start creating issues and kind of weird artifacts. Let's add creases, even more creases. Now this is, you know, a perfect box, you know, a perfectly sharp box. And in here it starts behaving a little bit strangely. If I were to select this and type in emap and try to show it to you, you can see that the behavior of it here starts becoming a little bit questionable, you know, in terms of how the reflection bends and what happens. Everywhere else is pretty fine though. So I don't like creases. I prefer this kind of a emap, this kind of a sharpness in the model rather than a perfect, you know, very, very, very sharp corner. Unless I'm working with Nurbs, then of course everything is sharp. Anywho, close that. And that is the main kind of, not culprit, but that's the main design method or design technique with SubD, is that you push and pull on the points or on the edges to squish them together to create sharpness and to relieve sharpness. And you always want them to connect perfectly. So a few things of what you shouldn't do, of how SubD doesn't work. if I were to create a SubD plane, let's say like that, right? Tab it. It's just a plane with, you know, again, these two edges, so I can kind of sharpen up one corner or the other. And if I were to create a face somewhere here, bam, like that, oops. Again, SubD face, that, enter, like that. For some reason, it's always inside out. And I want to connect this one to this one. They are touching perfectly, like they are on the same line, so they should connect, right? And they did connect, but if I hit tab, you can see that only this corner connected. For some reason, this corner gets rounded off and it doesn't connect. Why is that? That is because for SubD to work, all of the vertices need to match up. So this point right here, this vertice, does not have anything to connect to on this edge. So the closest area where it can connect is this vertice right here, right? So if I were to move it from here to here, like that, there are still, it's still not gonna work because there are still two of them here. So we would need to merge them together. And the way you do it is if you just somehow select them. Yeah, I'm just Control Shift and just dragging around them from left to right. Two SubD vertices added to selection. And then if you type in stitch, enter, stitch location average, enter, they're going to be merged into one. So and then if I hit enter or tab, sorry, then this whole thing gets smoothed out, right? So that's how it works. Why is this? Just a second. Ah, there we go. So if you'll see this kind of a behavior where it's kind of smooth, and then makes a break here, you just need to select the point here and type in RemoveCrease, and that's going to remove the crease from the point, and then you have the full-on smoothness. So that's okay. That is the behavior of SubD, and you can achieve quite complex things really quickly. And if you really push it hard enough, you can I mean, there's nothing that you can't model with this technique. Not to say that it's impossible to model the same thing with Nurbs. It is, absolutely. It's just that SubD is much faster at that. I think we need an example. So I'm going to use this as an example, as an exercise for me to rebuild this in SubD to showcase to you of the thought process of how I would kind of build this as a SubD geometry. So you can either start from scratch, right? Like that, and we scale this down like that, and you just kind of start moving things around and modeling things as a SubD geometry. But what I really like to do is I like to dress things up, retopologize things with SubD. So I'm going to select this shape right here. I made a copy of it, as you noticed. I will lock it, and now I will start creating SubD faces on top of it, on top of the locked geometry. So for that, I need a new layer, and I'll call this layer SubD. And that's a very poor way of writing it. SubD. There we go. This time I am going to color it. It's going to be blue color. And I'm just going to start drawing, right? So create a single SubD face. That's my thing, my jam, like that. And I'm just going to draw the simplest one right here, this rectangle. That's easy. That's what I like, right? So okay, that first rectangle was easy. Now I need to somehow draw a second rectangle, and let's say it's gonna be something like that, right? That's my second rectangle. Remember, and I'll just hit enter for just a second. So I have two of them. Remember that problem where it didn't match up here? Sorry, where this point it didn't have anywhere to connect to? I just explained it, right? That means that this rectangle right here is not good enough. We need two rectangles here. So to save us some time, this rectangle will be drawn last, or this area will be filled in last, because it will need to eat up all of the geometries that will come from here, from this area, right? So let's do that. Whew. 3D face, and here that seems like a pretty good rectangle, right there. Then we have 1, 2, maybe something like that. That's also fine. This immediately starts looking like a problematic area, but I'll leave it for a second, like that. Join all of these up. So I'm just selecting all of them and typing in join. Hit tab. It smooths out quite nicely, but this corner seems like it's going to be a little bit of a problem. We will fix it later. Now I really wanna speed it up without me explaining too much, but let's just do a few more, just so that you can see my thought process on these. So I'm always doing rectangles, always. Never anything else. Like that. Then this goes in until here. Like that. This goes until here. Like that. This is gonna be a weird one because you can see that let's flip this. Here I have a triangle, basically. That you know, it wants to be a triangle here, and at this stage I really don't want it to be a triangle. So I'm going to figure out a way of how to make it into a rectangle, and I think a way is if I do if I grab this point, for instance, and I type in move, I will just kind of squish it to the side like that, so that we can have a very long boy right here. From here to here to here to here, and now that's a rectangle. Typically you should look at the proportion of your rectangles, but in this case we whatever. So we have that, and let's just join all of them up. Now I'll really quickly show you the behavior of this SubD geometry. And you can see that it's smoothing itself out as it's transitioning from one box to the other, right? That's what we want. Well, at least at this stage. Later we will be fixing it. 3D face. Let's do this one, because this one seems to be simple. This one has to be a triangle. There's no way to not have it as a triangle, so fine, we will have it as a triangle. As long as it's not an n-gon, we can work with it. Once it's an n-gon, then we can't. N-gon is anything that is larger than that has more corner points than a rectangle. No, pentagon, hexagon, septagon, octagon, all of these. All right, so now this is definitely the time for me to speed up the video and basically go around this whole thing and create a SubD version of it. Okay, there we go. So here it is. It took me, actually I can check because I have it all recorded. That, pause that. 30 minutes. So it took me 30 minutes to reach this this 3D model, and it's far from being finished, but it's at a good enough state where I can kind of move on with modeling. And the main and important thing that I want to show you now is the cleanup process. Because as I was modeling, I of course made a few mistakes. You know, there were moments where I would miss the anchoring, the snapping of the vertices. There would be moments where I would kind of mess up the edge flow of the elements, and I assume I have at least one pentagon here. Anyway, I'm going to take this object and I'm just going to make a copy of it to the side. This is what I have, right? And I'll hit tab just to see how it looks like when it's moved. So it looks pretty cool, pretty neat, but there are visual kind of problems with it that I immediately see. You know, the hell is going on here, something's wrong here, the backside is just a complete mess with a hole right here, and so on, right? So there are quite a few instances of it failing, and I'll go through these, and I tried to make a few mistakes on purpose just so that I can talk about them. So I'll go through these and show you how you can fix them. So let's hit tab again. So the first thing is every time when you see that the back faces are still turned towards you after you've joined everything, indicates that there is probably an issue with the model somewhere, right? So the issue might not be necessarily here, it might be here, and this will still reflect it, but and also I forgot to add a bunch of stuff here, doesn't matter. We will be doing that right now. Or actually, I didn't forget. I have added, I just didn't join them. So sorry about that. Let's delete this, and this time around, let's make sure that everything is joined. There we go. And now let's make a copy. There we go. Now hit tab. Okay, great. Now at least we have these. Still, same problems, right? Red faces indicating that these are the back faces are popping up here and there. There are some instances of the edges being shown in the blue as a blue line, not as a black line, and that will, if we type in options, just type in options and go to view, display modes, shaded, and here you can, under objects, under SubD, you can change the settings for different edges of the SubD. So for instance, wherever it says crease, right, or boundary edges, you can change the thickness of those edges in pixels to be thicker, right? So let's say 4 pixels for each. Hit OK. And now we can see that these boundary, like this edge right here, really shows up thick for us. And that is important because we want to see where we have these boundary edges. Because if I have this selected and I hit tab, you can see that the problem actually happens on this edge. So there are two reasons why you might encounter these kind of edges. One reason is if you have two vertices in one position that haven't been joined into one vertex, that haven't been merged. How do you check for that? Well, you can always right click the wait. Yeah, you right click the perspective name, right, of your viewport, and you choose wireframe view. And then with Control Shift and dragging from left to right, you drag around the problematic areas. So for instance, here it says one SubD vertice. Okay, great. That means here we only have 1 point. That's excellent. What about here? I can immediately see that here we will have 2 points, right? So these need to be merged. How do you merge them? You use a command that's called stitch. By the way, all of the commands, I will list them in the, let's go for video. In the video description, I will list all of the commands that I'm using in regards to SubD, so that you kind of don't forget. So you just can kind of copy all of them into a file and into a notepad file and have it somewhere near you. So these 2 vertices, I will type in stitch, enter, and what stitch will do, it's going to ask me what's the position of the point to which the 2 points will be merged, right? So I can either choose this position right here. Wait, let me zoom in. So you can see here, I can either choose the left or right position, right? Or I can choose it to be average. So in this case, I will just choose average. So I just hit enter again, and it basically just finds the middle point between the 2 points and merges both of them in there. And now if I go back to my shaded view, you can see that here all of the edges are correct. And if I hit tab, this area right here has been solved. It's now smooth and nice, right? So we can continue. Looking at it here is another problem. We encounter, rather, another problem. See this edge and this edge? These 2 edges just arrive at this edge, right? And they don't continue, right? It needs to be like a grid, right? So you can't just have that. That's the same problem as what I showed you before. Let me show you again, just to really condense it like that. You can't have an edge just arriving towards any other edge in this way. It needs to be point to point connection like that for it to work, right? And in this case, it would need to be actually like that, right? So how can we solve this? Wait, where is it? There we go. How can we solve this? Well, we need to introduce 2 lines, right? One line going on like so, and one going on like so. We could redraw the whole damn thing, but that takes too long. So instead, I'm going to use a command that's called insert edge. Insert edge. The way it works, it basically asks you for series of edges, or one, doesn't matter, from which it's going to offset a new line of edges. So let me show you this on a much simpler, on a much simpler example, right? Insert edge, like that. Select edge from loop, there, for instance, enter. And you can see that now I'm able to insert an edge to the right or to the left of this initial edge loop, just like that. And then again, I can insert it like that, and so on, right? So insert edge. Oh, by the way, once you start messing around with the topology too much, so for instance, here I messed it up quite a bit, and here I created a pentagon, right? So now insert edge will behave in a very weird way. That's why we don't like pentagons, by the way. So always try to keep a grid. Don't forget about double clicking to get the full edge loop. And that's how it works, right? So to repeat it here, I just need to select the correct edges. So I'm just going to go for the bottom border here, like that. These edges right here. And let's change colors, because this is becoming a little bit too... Yeah, I think this is nicer. So bottom edge, all the way, right? And then I type insert edge, and then I just can drag it and click on the vertice. But before I do that, notice how it moves. It moves as if it's being offsetted. We don't want that. So where it says offset mode absolute, that is in meters in this case, we will not use absolute, but rather we click on this, offset mode proportional. Now it's going to move in a proportion along these kind of cross-section edges. I can't show you because I'm using my mouse. So these cross-section edges along which we are moving, the newly created edges, now it's following a proportion, while before it was using an absolute number, right? So I hope it like this makes sense. So we insert the edge right here, like that, and double click. We will insert the edge right here, like that. And now this should be fixed, but this is still a messed up. This area is still messed up. You can see because it's not drawn as black. And also it's a thick line. So that happens because these 2 points here, even though we now have a correct edge flow, the points are not connected. They are not merged. What do we do? Well, wireframe. And then in the wireframe, we try to figure out where the hell we are. Okay, let's try again. So I'll need this. Okay, let's go to wireframe. And now let's try to select both of the points there. You can see 2 SubD vertices are selected. And then we do stitch to average. So stitch, enter, enter. Same thing for these two. Stitch, enter, enter. And I think that's that. Let's see. Yeah. Now the edges are correct. And we hit tab and it's all rounding off nicely. More problems. Oh, there we go. There's an issue here, right here. So here it seems like the edge, like the way everything's connecting is correct, except for, well, now we definitely can see that there's a problem here. Let's change to ghosted view. And now I can really easily see that there is a point there. This point right here, which shouldn't be where it is, right? So I misclicked. So I'm just going to select, oops, come on, stop that. Select these 2 points, Control Shift and select, and then I'll stitch them. Stitch, but not to average, but this time I will click on the correct one right here to have them stitched. I hit tab. Now this whole thing behaves properly as I want it to. All right. Last thing is right here, and it's going to be a little bit more complicated. That's why I left it at the end. Same problem, right? This. So we should be able to insert edge and kind of fix that. But the question is, you know, if we insert edge here, right? So the edge loops around here and goes all the way around here. Where does it end up, right? So if we were doing this, we would initially be creating an infinite spiral that just keeps going around and around and around. So we need a strategy, is what I'm saying. And the strategy that I am thinking of using, sorry, I need a second to think. Well, first of all, we definitely need to insert edge here. So there needs to be one here, and there needs to be one here. That's for sure, right? Then these two edges, as they're going out here, perhaps they could be merged. So this one could be merged into that corner right here, right? So I'll just use stitch and just stitch it to there like that. And then for this one, I could do this, right? I could stitch it to there, but that's not that nice. So instead I will try to figure it out. So I'm gonna delete this. I'm gonna delete it. I'm going to do a 3D face and just try to create some sort of a yeah, that's a quad, that's correct, and that's a triangle. So I'm just kind of creating a new, all I did was just create this edge right here inside of that form. Wait, is that still a quad? 1, 2, 3, 4, 5. God damn it, that's a pentagon. We don't want pentagons, right? So instead, we are going to do a triangle here and a quad here, like that. So any kind of a pentagon can be divided up into a rectangle and a triangle, right? A junction between the two. Then here, I will just use insert edge easily to just add an edge like that. And here I will also use insert edge like that. And you can see that it almost automatically kind of connects here, but it's actually lying to us. It's not connecting. So I'm just going to use stitch to force a connection to here. Okay, so that's solved. That should be solved. So all we need to do is stitch a bunch of things together. Okay, let's do that. That's one vertice. That's great. But here we will have two vertices. Stitch, average, great. By the way, if you don't like switching between wireframe and shaded view, you can always do the filtering, right? So you can see here in SubD tools, selection filter edges, selection filter faces, selection filter vertices, right? So if I click on selection filter vertices, if I click on that, this little guy pops up, and that means that now I can only select points, nothing else, right? I can't select, I'm now clicking, I can't select anything else. So if I drag around, oops, why can't I drag around? Oh, I don't need to drag around, sorry. I don't need to hold Control Shift anymore. So if I drag around, I only select the points. I don't like using this because I constantly forget that I have this on. Then I spend some time trying to figure out why the hell can't I select a rectangle. But honestly, it's a pretty good tool. So now I have two SubD vertices selected. That, stitch, enter. Now they're fixed. Now this one, same thing, stitch, enter, hit tab. Everything gets kind of cleaned up except for this corner. But remember what we do with the corner. We select it and we type in RemoveCrease to remove the crease from the corner. Hit tab, and now it's all neat and dandy. And you can even see the proportion here, right? So in this area, it's less rounded. It holds its form quite well, while in this area it's super loose, because here it only has 2 polygons, while here it does have a kind of neighbor next to the corner, right, which holds its proportion. I find that to be both interesting and also hard to work with, but once you get used to it, it's great. Oh, there's a little bit of a doozy here. Do we just hide our crimes? Yeah, let's just hide our crimes. So this and this stitch to there. It's just becomes a triangle. Well, actually, we shouldn't do that, should we? I should instead. Wait, how will this work now? By the way, to disable this, you click on selection filter none on this icon. Bam. Now everything gets tick marked, and now you will be able to select whatever you want again. So let's do that, and yeah, that should be fine. So let's do it this way. These three edges, insert edge, kaboom, like that. Then I will go for wireframe and just stitch these guys together like that, and then stitch these guys together. Okay, so that fixes the problem. The hell is going on there? Oh, it's just, yeah, it's just the way this is assembled. We don't even need this polygon. At least I don't think we do. Okay, great. I'm just checking for any more mistakes. Give me a second. It doesn't seem that like there are any. So this is like step number 1 in terms of creating a SubD geometry, right? Between the two forms. Step number 2 is to actually control how smooth things are in certain regions, right? Because you don't want everything to just be a blob. You want certain parts to be sharp and other parts to be smooth. And I'm keeping this open on purpose. We basically want to work with, we don't want to cap it just yet, because the caps will probably be a little bit difficult to make, and also with every adjustment we will need to change the caps, so we're gonna do that later as a final step. So when I talk about introducing, what's the word? When I talk about introducing sharpness to the model, let's for instance continue on with this opening right here, right? So it could be how do I explain this? Like the seam here, you can see, because these two polygons or these three polygons are these three sides of the box are rather not subdivided. Well, this one is, but these two are not. They're not subdivided. This will round off the most, then this one rounds off like it's second place of how much it's rounding off, and then third place and fourth place, right? So it all depends on how close things are. And there are two ways of how you can work with this. One way is by introducing chamfers, and I'm going to show you a chamfer with this. Sorry, not a chamfer, a bevel. So I've selected the edges and I type in bevel, and I will say 0.1 with one segment, right? So segments, I choose that to be 1, and 0.1 in terms of how much I'm beveling, and you can see that instead of one edge, it just creates 2. And now if I hit tab, you can see that this becomes much sharper, right? This is how it was before, and edit, redo, this is how it is now. So that's one way of how to do it. I kind of do bevels last. I don't like to add bevels during the modeling process, because they tend to mess up my jam, so to say. Any amount of bevels, let's say I am selecting this and I'm creating a bevel, right? Sorry, well, it created a bevel all the way through, but And anywhere where you add bevels, it will create this kind of a triangle at the end of it, and we want to minimize those. So I'm trying not to use any bevels. Instead, I'm going to sorry. Instead, I'm going to work with insert edge first. So for instance, for this surface right here, for the top surface, I'm going to select all of these edges, and I'm just going to try and see how insert edge will behave. And you can see that it doesn't like it, right? So we will need to be a little bit more manual about this. So I'm just going to go one polygon at a time. Like that, like that. Oh, this one needs to be pretty small. Then here we actually will need two, or we could just make it, we could just force it into a single triangle right here. But that might be a bad idea, right? So you can see that as I'm doing this, the retopology of the mesh, like me recreating all of the triangles and all of the quads, that would take another half an hour probably, something like that. And let's just say we're impatient and we want to make it faster. We want to go fast. So one way of how I would attack this would be if I select a surface, you know, this surface, for instance, and I know for a fact that I want to keep the planarity of the surface. I want to kind of, what's the word? Sorry, give me a second. I want to tie it. I want to protect, yeah, that's the word. I want to protect its borders, its perimeter. To do that, I need to double its perimeter. How do I double its perimeter? Well, if you have outline, you offset it inwards, right? And thus you double it. What's an offset inwards? Well, that's an inset. And that's exactly what we're gonna do. So I select all of the surfaces here of one that are within one plane that I want to protect. I select all of the surfaces and I type in inset, enter. It asks me for a mode. It can be either mode group or mode single. I'll show you first of all the correct way of doing it, and then I'll explain the other mode. So mode group needs to be the one that we use. Once you see mode group, we hit enter, and then it asks us for a distance. So here in meters, we need to specify by how much are we offsetting inwards. And I'm gonna say 0.1 is actually pretty good. Let's go for 0.2, just because. 0.2, hit enter, and that's what we get, right? We get a nice little offset all around the perimeter, except here. Here it kind of messed up, but that is actually fine. I believe if we just move M, enter, move, short for M, or M, short for move, M, enter, and we, with nearest snapping turned on, oh, you can't really see it, can you? I'll close that for a second. With near snap turned on, I will just move it along this edge. So I'm just snapping to this edge, you know, to a more correct position. All of this is done by eye, by the way, no measurements. And you can see that now the top plate is much more controlled, right? It's much flatter. I'll repeat it for the side plate here, this one. Inset, enter, group, 0.2, enter. Now this is flatter, right? And they both are holding the crease right here. And I'm just gonna keep on doing this for every single surface or plate that I have. Inset, group. Great, that's what I wanted to show you. So in this case, you can see that the inset messed up, right? And it messed up here because the gap between these 2 points is smaller than 0.2 times 2, right? So it intersects with itself, right? As it's trying to inset. So here, here we can't really do 0.2 inset. We need to do something a little bit less, drastic. So, or a number that's a bit smaller. So I'll do it again. Inset, group, 0.1. How about 0.1? 0.1 seems like it's gonna work, so I'm gonna stick to it. Hit tab. You can see that now this is also sharpened up, and we have one side of the box being, or not the box, sorry, the SubD being sharp, right? So now we can continue on with this approach. Inset 0.2, back to 0.2 method, tab, and you can see that with sharpness, like with introducing sharpness, you're also introducing tension in the structure. So that is like level 2 of thinking about SubD geometry. Is you think about how will the tension spread throughout the geometry, and that is honestly a pretty hard thing to do, but it is doable. It is doable. It's just you will need a little bit of practice. So I showed you all of these tools just to kind of get you started, and I'll undo this a few times because I like the smooth version of it. So I showed you these tools to just get you started using SubD. You don't need to use SubD. That's not the point of this. The point is to give you as large of a variety of possible modeling techniques as possible. There will be, of course, more stuff that I will show you in terms of modeling. But what I really want you to do is to choose a style, an aesthetic, maybe an aesthetic. Choose an aesthetic that you enjoy. In this case, I just booleaned together a bunch of prismatic boxes, right? And I'm just looking at what I get from it. You know, if I type in clipping plane, then I would kind of start investigating the cross sections of them. Oops. And just taking a look at how do the spaces inside behave, right? And what kind of spaces I could arrange on the inside of these. But just like that, you can also work with right, with a surface. You can have a surface-based approach where you just kind of start twisting, pulling, and turning a shape, right? And keep in mind that if you have this kind of a shape, right? One more technique, one more important thing to kind of showcase is that the gumball has these round circle things on each of the axes. These, like with this you move, right? With this you extrude. So you can take the gumball and you can extrude out, as long as you have edges selected, right? You can extrude out more polygons, and then you move them, right? And then you extrude them again, and then you rotate them. Not sure what I'm doing here, but sure. Rotate them. You extrude them again, and so on, right? So you can get a pretty interesting shape pretty quickly. Oops. Let me just real quickly do one thing. Bear with me. Like that maybe, and then like that. Something like this, and then like that. And then we need these to match up, right? So maybe that's gonna go there, and that's gonna go there. And that's gonna be somewhere here. I'm just matching up this edge with this edge, and this edge with this edge. Just trying to get a pretty nice flow between them. Like that, and then this one is, let's see here. Right, so a few more things to show. I showed the extrusion. There's also ExtrudeSubD command, but the way it works is a little bit awkward. Like it's I will show you ExtrudeSubD later. For this particular exercise, just use the gumball, and keep in mind that you can change the gumball direction by using C-plane 3-point, right? So you can change the C-plane right just like that, and then your gumball will be different, so you will be able to extrude in other directions. And then once you're done, C-plane, WT, W enter, T enter. Okay, more tools. SubDLoft or bridge, whichever you prefer. SubDLoft also works between curves. Bridge only works between SubD edges, but bridge is faster to write. That's why I use bridge all the time. So what bridge does, if I select these two edges right here, and I select these two edges these two edges right here, right? So these 4 edges in total, they need to match up, by the way, 2 with 2, 3 with 3, and so on. And I type in bridge, enter. It just creates SubD polygons between them. Hit OK. Hit tab. Wonderful. We have ourselves a little ribbon going on. Let's move it out of the way so that it doesn't intersect. Right? A great little ribbon. I'm just scaling it down so that it's a little bit more architectural, so to say. But yeah, we have that. And let's just rotate this maybe so that it opens up a bit more, and then move this out like that. Great. Architecture. Now to add thickness to this little guy, for instance, you can either select a few faces, for instance here, and just extrude those like that, but that's not going to add thickness. That's just going to kind of lift them up in this case and create a perimeter polygon group around them. Sometimes that's what you want to do, you know, just to get this kind of a puff going on. But in this case, we will be using something else. We'll be to give it thickness. We'll be using OffsetSubD. OffsetSubD. Select objects to flip offset direction. So we can choose in which direction we will thicken the SubD geometry, or you can choose to do it on both sides. So In this case, I'll use both sides. Why not? So both sides, turn yes, delete input. So would we like to keep the original? Nah. So delete input is yes. Solid. If this is turned off, it's just going to create two surfaces on both ends. If this is yes, then it's gonna create a solid piece. So in between the two surfaces, you'll have a ribbon going on. And then the distance. The distance is 5 meters. That's too much of a distance. Let's click on the distance and change this to 0. Whatever the concrete slab would be. 0.2, I guess. 0.25. Enter, enter. We have ourselves a thickness. And you can see that it automatically gets creased, right? So this perimeter gets creased. If you don't want that to happen, you can always just double click, Ctrl-Shift double click on the two perimeters that were created and type in RemoveCrease. And then it's gonna be very blobby. Oh, and I forgot the interior ones, RemoveCrease, and now they're blobby. If you want to bring back the crease, but you don't want it to be that strong as you know, just a regular bold crease, you can do that by, again, selecting the perimeters. This time I won't forget the interior one. Interior ones. And I accidentally clicked on the wrong one. There we go. There we go. So 4 perimeters in total. And you can type in Bevel. Bevel. Remember Bevel? I showed you Bevel. Bevel. Enter. Segments 1. Offset mode. Sure. Absolute. Whatever. And we just type in whatever bevel amount we want. And I will move the mouse just so that you can kind of see what... Oh, it's freaking out. So that you can see what it's doing. Instead of 1 line, you get 2. That's about it. It's like a chamfer. If you know what a chamfer does, then you know what a bevel does. So, amount to bevel. If our thickness is 0.25, then our bevel size is going to be like 5 centimeters. So 0.05. Even less, 0.02. Enter. There we go. Created a small little bevel. If I hit tab, you can see that now we're back to where we were, except that it has a little bit of softness around the perimeter, which is kind of nice. Emap. If I emap this and I change this to arches, there we go. I can see that it's, you know, pretty usable for architecture. You know, as a beginning thing, at least. It has some interesting areas to explore. Anyway, so that is another way of how you can work with SubD, right? With Nurbs, you could do this exactly same thing. I would the way you would do this with Nurbs would be, you would need to draw the outline curves, right? Something like that, and then we lift it up, we bend it onto itself. So I just drew like a perimeter curve, and now I'm just playing around with it. It's probably gonna be a mess because I'm now a little bit rushing. Sure, but you do that, you offset the curve. Let's just see if that's gonna work. Offset with distance, I don't know, like the thickness that we had here, 10 meters, something like that. Enter. It doesn't work, so we need to change something. Loose, yes. If it doesn't like to offset, then you change this to loose. Enter. Still doesn't work. Oh yeah, don't forget to click the mouse so that it offsets. And then you will notice that the offset will generate sharp corners, which we don't like, because this is all nice and this is not. So what we will do is we will rebuild the two curves. We select both of them, we type in rebuild, we choose like a decent amount of points. Let's go for 20. Something like that, yeah. 20 points. And you can see as you rebuild the curves with 20 points, it becomes softer. And that's because you're reshuffling where the control point positions are, and you're forcing it to soften out the curve between those new control point positions, so it forgets its corners, basically. And then we just loft between these two, like that. We get ourselves a ribbon. It's, you know, it's a ribbon. Then we can actually use Control Shift. No, we can't, sorry. Before you do the ribbon, before you do the loft, you need to, you know, make any adjustments to the geometry. Oh, by the way, one little trick that I like to do, so that I don't need to loft constantly, right, over and over again. One thing that I like to do is in Grasshopper, I just create a curve component. I right click, set multiple curves. I link these two curves, right, into Grasshopper. And then I just create a loft in Grasshopper so that it constantly shows me the geometry, right? And how the geometry is gonna look like. So now if I were to, you know, select this curve and just move it out, it all follows, right? Which I find to be quite nice. Right, so now I can mess around, oops. I can mess around with the control points, and it's going to follow along. The more you mess with the control points, let me really mess it up. Like that, lift it up, bring it back in. Not good enough. Okay, let's mess it up on the other side as well. Bring it down like that. Still doesn't break. Every time when I don't need it to break, it breaks, but when I need it to to break, it doesn't. Anyway, so now now I can't force it into a break. Sure, whatever. We're gonna have it. Let's just say that it never breaks. It always works perfectly. Nah, if it does, if your loft will start looking really funky, that means that the two profile curves that you're using are too different, right? They're too, their lengths are not matching up and they're too messed up. A way of how to solve that, and actually let me try and show you that. Once I've done that, by the way, I just delete the curve loft tools here so that they're not in the way of my beautiful Grasshopper script. Let's just loft between these two like that, and you can kind of see in certain areas the edges, the edge flow of the loft are, you know, it's a little bit questionable, right? So let me flip this around so that you can see better, especially here, right? It's kind of bending onto itself and it's all weird and funky. So more control, if you want more control with your loft, then you can create a polyline or a line segment, and you can just draw line segments going through the loft like that between the two curves, right? So you can be very specific as to which points you want to correlate between the curves. Then that, maybe that. I am sure that I'm gonna make a mess right now, but that's how it's supposed to be done. Okay, let's see something like that, right? I drew a bunch. And then you don't use loft, you use sweep between two rails. You select the first rail, you select the second rail, and then you select the sweep shapes. Bam, bam. Well, you can actually just select all of them. hit enter, it creates this sweep, which forces it to follow the lines that you drew. And also to make it closed, you just click on close sweep, like that. If there is still a problematic area where you think that, you know, here it should be more of a this angle, not that angle, or let's find a more problematic area. There's none. God damn it. I did it too well, of course. Anyway, if there was, let's say here, you know, some sort of problematic area where the lines are not matching up that nice, you can also always add slash, and you can click on the first curve and click on the opposing corner of the second curve like that, and it's going to add the slash, right? And if you don't like it, you can click on undo, and it's going to remove the slash. So you can keep on cleaning it up until you find it to be, you know, exactly the way you want. So this is more of a advanced thing, but if we were to check both of these, like this corner right here and the way it reflects with this corner right here and the way it reflects, like it's like night and day difference. I'll show you this with fluorescent tube. You can really see the shitty reflection right here. And in this case, it's so much cleaner, right? So yeah, that just helps with the surface quality in general. We will be using that later in our attempts to join the geometries with the landscape, but that's gonna come in day 2 of our workshop. For now, coming back to this little shape right here, there are a few instances here and there where I do want it to be a little bit more pronounced, a little bit better behaved, so to say, but all in all, I do like it. I don't like this dimple though. Like this dimple makes no sense, so I'm going to get rid of it. I don't care for it at all. So I'm just gonna remove that. Probably that. So for instance here, right? This edge and this edge. If I wanna just get rid of this edge, let me first test it, sorry. I'm gonna test it and just see. Okay, great. If you want to remove a single edge, you can just select it and hit delete. I was afraid that it's going to keep the 2 endpoints here, but it doesn't, right? So it's all neat and dandy, like that. And then here we will have 2 triangles to deal with, and I think we can like just do a 3D face. Just add a triangle here, add a triangle here. Technically, we could say that it's a quad, but it's not a quad. Who are we kidding? It's 2 triangles. So it's not the best topology, but it is what it is. Right. So now I don't really want to move any further than this on day 1. I want you to kind of create a vision of your geometries, right, of your aesthetics. And I want you to really experiment with both the Nurbs type of geometry and SubD. Just give it a whirl, just try it out. And once you've done that, then show selected, find your landscape, bam, and just drag it in. Just see how the piece will sit in your landscape right here, for instance, right? And I guess we need show selected. We need a little bit more data here to really make it work. Honestly, I kind of want to project a few things. So before we finish, let's project at least the tree, not the tree, sorry. Let's project the city information on top of your landscape, on top of your landscape surface. This might be a very heavy operation, so please first wait for me to do it, and let's just check if it's gonna work. And I am going to save the file. I am going to save the file. And let's just make sure that it works. So in Grasshopper, I will type in srf surface, right click, set one surface, and I'll link my landscape surface to Grasshopper. And then here, all of these curves, this group of curves, 28,000 of them to be precise, I will try to project on this surface. So let's try that. CRV, curve, set multiple. There we go. So now all of them are linked here. Oh, there's even more, but later. For now, this is good enough. All of these, and we will do project. Project an object onto a plane? No. Project a curve onto a B-rep? Yes. B-rep is boundary representation, by the way. It's a surface or a poly surface. That's a B-rep. Okay, so project a curve onto a B-rep. Yes. We select our curves in Grasshopper. Those are the curves that we will be projecting. I will save every single thing that I possibly can. And then I'll just connect the B-rep. Oh yeah, and before I connect the B-rep, the surface, I will need to specify the distance. So the distance, direction. And the direction is going to be, again, downwards. So Z negative. That's downwards. And the surface, let's see. Really? That is impressive. It just straight up projects it without any problems whatsoever. I'm impressed. I am impressed. Which means that now we can finally hide the ugly CAD data. And of course it still shows in Grasshopper, so let's hide that. And we will see only the projected portion of it, only the part which we care about. So now I can bake these out, right? So let's create a new layer. So now you can follow along, by the way. It didn't crash. That means it works. Let's create a new layer and call it projected CAD data. And let's just bake this out to projected CAD data. Hit OK. Then disable preview of everything here. And group this. Hurrah. One more script. Okay, so now we have a bunch of curves that are projected. So at least now this landscape contains a little bit more information as to where things are. And this is in the way. So let's just see where we can put it so that it's not in the way anymore. Maybe let's just hide it. Sure, why not? Okay, so now I can take the SubD and just find the placement for it where I want. But the problem is that I am not sure as to where I will put it, and I'm not sure how the landscape around it will look. So what I kind of want to do is just put it sideways, right next to the landscape. Go to the top view, just like that. And we can change this to Arctic view if you want to, for it to be a little bit more, a little bit cleaner. And I'll do view, capture to file, right? Where I'll say viewport aspect ratio. So resolution is driven by the viewport. And the scale is 2. So it's gonna scale it up 2 times. Hit OK. Let's just save it to desktop as, or not necessarily desktop. Let's go for AHF30. And let's just call this top view. Hit save. It's gonna take a little bit of time. Open up Photoshop. We can delete this layer because we will be using a new one. That's the wrong folder. Just a second. There we go. Top view. And I'll just drag and drop in the top view file onto here, onto Photoshop. And I'll make it bigger, of course, like that. Because this is honestly the area about which I care. I will right click on the layer and I'll choose to rasterize it so that I can then cut out the little doodad, not sure how to call it, like the base of the building or the building. And I'll choose to multiply the building layer. So now I am able to move it around freely and just position it. Oh, by the way, if you don't get the white background, sometimes students don't know this. If you don't get the white background, you can change the background color under display. And if you don't see the display tab, click on this little gear icon here and choose display. But under display, you can change the color of your background right here. Background, solid color, color white. Just so that you know. Back to Photoshop. Here, now I am able to move this around, right? And it does have a kind of, at least a somewhat correct proportion, correct position, right? I'm able to, with the transform tool, Ctrl T, rotate it around to figure out the correct orientation for it, right? And I will be able to draw. Let me move my keyboard away. So I will be able to also draw out the additional kind of landscape things around it. Let's jump to 100% preview. And let's just kind of go to town at it. So I'm not going to show you, how I would kind of sketch it out, because I don't think it's that important, honestly, because everyone has their own style and their own approach. But I would definitely kind of check out the bus stop. I'm not sure, is this the bus stop though? Feels like it's the bus stop is here, and then they take a turn around and they go back. Or maybe I'm in a completely wrong place. It's late now. I'm tired. Anyway, around the building, I would start thinking about how, what would be the central plaza of the building, the gathering space. How would I make it so that the staff would be able to arrive? Where would I hide, or not necessarily hide, but create a space for staff parking, and how I would separate it out from from the plaza, right? From the central plaza. So then I would need to kind of figure out a pretty decent connection to it, you know. So how would the road look like? So for instance, okay, one thing that I can speak about. So let's say we are creating a road here, a new road. We're getting rid of this one. This one's ugly, right? And we're creating a new one, a new road here for the staff, not for the people, or not for the visitors, right? So if we do it this way, that means that, okay, people go in here, they drive up, and as they're driving, what do they see? They see the whole building. Or sorry, what does the staff see? They see the whole building, right? So as they're kind of going together, they get introduced to the building, and they park here, and they have their little door through which they enter the building. Great. So it would be so much better if this happened to the visitors rather than the staff, wouldn't it? Right? Because then the visitors would be able to, if they park here in this area, let me change colors and make this smaller. If they park in this area, right? And there is like a separation here, they could easily move out into the central plaza, right? Into this kind of cool outside area, and the entrance to the building would be located here, which makes perfect sense, right? Because if we look at the architectural design of the boxes that I've made, like entering through here would be a, I mean, it's a pretty cool volume, right? If let's say the landscape just dips down a little bit, and then there is kind of an entrance, and then as you enter, there's like 1, 2, 3, 4 windows looking out. Let me change the lens length to like 20, right? So you enter into this kind of a space. I think that's pretty cool, right? Right. Anyway, so that's the idea, right? That you want the entrance to be here. Okay, go back. If the entrance is here and not the staff but the visitors are parking here, right? And as they are approaching, they see the spikes, right? They see the main attraction of the building. Okay, we have a story here, and for them to enter, the landscape will need to dip down. That means we are removing this. We're starting to kind of create a pretty interesting, not a pretty interesting, but we're starting to create a strategy as how we will approach this building. So then the question is, maybe the parking shouldn't be here for the visitors. Maybe the parking should be here, right? Because then the staff parking could still be here, but it could be approached from this side, you know, from this road right here. So we have 1, and then the second one is here, right? So we're creating 2 roads. Then the question is, do we need to create a long ass road here, or maybe it would be good enough to just kind of draw or create a road here? And my answer to that would be no, this is not good enough, because you would be sacrificing the introduction to the building aspect of it, where you're approaching the main facade of the building, so the effect would be less for the visitors, right? So these are the things that you should kind of think about and create a strategy as to where things are placed. And the next step, for instance, I'll just kind of go one more step forward and then we'll stop. Next thing is, well, if you have the visitor parking here, right? and the visitors approach through this road right here, that kind of messes up the view of this facade, doesn't it? Right, up from this direction. Well, not necessarily. If your parking lot is, you know, a concrete slab then of course it's gonna mess it up. But if your parking lot is actually incorporated in the landscape, so the landscape kind of surrounds it and the landscape behaves as if the building itself, as an extension of the building, then you can place anything there, that, be it cars or whatever, right? So we know that in this area right here, we will need outside, like exterior architecture, small architectural elements happening, urban architectural elements happening. For the plaza, we will need some sort of a way of how you enter the plaza. So I assume from the outside, if let's say you arrived by bus, you still want to have like a paved pathway through which you arrive here, and so on, right? So you start creating a strategy. Once you have the strategy in your head, then you will be ready to go with step number 2. That's going to be retopologizing, retopoing the landscape here, right? Or area of the landscape here to fit with what you want. And that is what I'm going to show you on day 2. This little building right here is going to be placed wherever we want it to be placed. It's going to be sunken in as much as we want it to be sunken in. And the whole area, the whole landscape area around it is going to merge with the building and make a single uniform object, or, you know, a coherent architectural piece. That is going to be very important. But that is going to be for the next day. For now, this is all I wanted to show you. So practice up, test out a few techniques here and there, and I'll see ya. Bye. Oh, I forgot. One more thing. I said that I'll show you how you can cheat. So let me show you how you can cheat. In Rhino, in Grasshopper, there is a way of how you can create the topology, the SubD topology automatically. So if I select this closed poly surface here and I reference it in as a brep, right click, set one brep, right, like so, and I go to surface, no, to mesh, triangulation, quad remesh. So I'll select this, quad remesh. This little thing right here, what it's gonna do, it's going to rebuild this whole shape in quads. So one thing that I really wanna test out is remeshing settings. Yeah, we want to first specify the settings of remeshing that we're gonna use. So under triangulation, where it says quad remesh settings, we're gonna use that node as well. So I'll connect that to the settings, and what we care about is the target count. Right now it's gonna create 1,000 quads, and let's just check, honestly, let's just check how it's gonna look like. So brep connects to the mesh input. Let's just see if that's gonna work. Yeah, that works. And immediately it creates a mesh, and it's a little bit of a mess, so I will disable the brep preview as well as the polysurface preview. Hide that, and you can see that the geometry that we get is not the best, not the cleanest, but it is there, right? It is there. So what would happen if we increase the target count, let's say to 2,000? Did it change? I can't tell. Wait, that's weird. Yeah, of course, it changed. So 2000, a little bit better. 10,000, even better. 10,000 is pretty damn close. Let's jump back to 1000 and let's see what kind of other adjustments we can make. So for instance, the guide curves, those will force the polygons or try to force the polygons to be placed on top of them. So if from this brep I were to extract its edges by just using brep edges component like that, and if I were to get all of the interior edges as my guides, let's see if that's gonna help. It doesn't seem like it's doing much. Well, it is what it is. Let's look at other things here. Adaptive size, a number in range in between 0 and 100. By the way, I didn't say that this is gonna be a good solution, but it's a way of how you can automate things. The reason why I didn't show you at the start, because I know that this will produce a much cleaner output than this, but it still kind of works. Adaptive size, number in the range between 0 and 1, controlling how quads, these rectangles, differ depending on curvature. Okay, what if we change adaptive size to 100? What will that do? Quads where it doesn't need to twist too much will become bigger, and where it needs to twist a lot, they will become smaller. Yeah, sure. Adaptive size seems great. Maybe we don't want to go full ham. Let's do 50, somewhere in between. Then, adaptive count. True if the number of quads is allowed to be higher for high curvature areas. Sure, that's fine. Hard edges. Detect and retain hard edges in the input mesh. Sure, let's try that. So we will toggle. We will use Boolean toggle, which is basically a button. Double click it to turn it to true, and where it says hard edges, we will connect that, and voila, you can see that now it's doing its best to keep the hard edges of the mesh. That's what we want. It's struggling a little bit because I think now it doesn't have enough polygons. So I'm going to increase the amount of polygons to 2000. That should help it a little bit. Seems like it's doing the thing. Then seam edges, same thing. We will just connect true to seam edges, see if that's gonna help. Doesn't seem like it did anything, but whatever. Then symmetry, there is no symmetry, so we don't care about that. And guide curves, approximate, well, it's how it treats these, so that's fine. Approximate is okay. Anyway, we get ourselves a mesh that is all quad and seems to be pretty clean. Then we grab it and we need to change it into a SubD. So how do you do that? You go to Surface, SubD, and you choose SubD from Mesh. As easy as that. You connect the mesh to the SubD M input, and that is it. You get yourselves a SubD. At this point, you can just bake it. Default or SubD layer. You bake it out. You move it to the side. You hit the tab button. And you can see your automated form created with a few a few questionable choices here and there, but all in all it's fine. It's definitely usable, well, except for a huge asshole that it created in the back, but can't win them all, can you? You can still kind of stitch it together and work with it to make it all work, right? So you can model on top of this. But yeah, That's how it works. This is, trust me, this is gonna be easier to work with than this. I'm talking from experience. But just for lazy people out there, this is a pretty good alternative, I think. Okay, and one last thing is this SubD Fuse tool right here. SubD Fuse. So the way it works is if you have two SubD geometries, let's just create, let's go to SubD tools and let's just create a SubD sphere and a box, maybe a long boy like that. And let's, oh wait, my perspective is all funky, 50 millimeters. A sphere, a box, and a cone, like that, right? And let's say I want to merge them together, right? I want to fuse them together. Well, that's what this is for. So if I create a SubD geometry, and we actually will need 3 of them, each for 1, right? Or 1 for each. Set 1, so that's going to be the cone. Set 1, that's going to be the box. And set 1, that's going to be the sphere, right? And now if I were to SubD fuse, so if I merge the cone with the box, right, it unions them together. And what else is there? What kind of operation you're going to use? So you can either union them or you can remove stuff from each other. So if you type in 0 here, if you add a 0 here, then it's a union. If you use 1 here, then it's going to be an intersection. So it's going to find an overlap between the two. And then there is 2, which is going to remove, wait, let me check. 2 is going to remove from A, it's going to remove B. So in this case, from the cone, it's going to remove the box, and so on, right? So let's use the fuse for now. Let's use 0. And for smoothing, yeah, whatever. I'm going to show you this later. Whew. If you take the cone and now move it close to the box, you can see that it just immediately connects it. And it's kind of hard to show you, so let me change this to wireframe so that you can see better. Right? These are separate, and now these are these are merged together, right? With a few problematic areas here and there, of course. There always are. And if I were to change this to 1, as I talked before, that's not what it should do, but it's doing that, whatever, sure. Let's change this to 2 just to see. Okay, that's wrong, and 3 is wrong. Never mind, we just use 0 because everything else doesn't work. And then if you want to fuse a third object to this, you can see that there's only 2 inputs. You do need to repeat the fuse command, right? So I'll just type in fuse again, SubD fuse. And now my A input is going to be the fused object, and my B input is going to be the sphere. Just like that. And then I move the sphere somewhere close, and now it gets fused to the previous 2 objects. Just like that. Right? So you can kit bash your stuff this way as well. And then if you bake this out, where is it? There it is. If you bake this out and you take a look at it in the shaded view, that's the geometry that it has created. I feel like that's pretty damn cool. You can do a lot of cool stuff with it, especially for 3D printing and kit bashing of different kind of aesthetics and styles. It's nice. So that you might find this helpful as well in your explorations. Okay, now we're done. I promise. Now we're done. Now, go design.